Hello everyone, my name is Binuka Kamesh. This is my video demonstration of my final year research project. The code name is CHORDEYE, and which is guitar chord recognition system using real-time video feed. So let's dive into the problem domain first. So the guitar is a string instrument which is one of the most famous instrument in the all around the world, and it has a large amount of a player base all over the world. So a chord is a grouping of three or more notes that are played simultaneously. So when we talk about guitar chords, there are large amount of guitar chords in the world. So it's all about the different hand shapes. So the problem is finding the chords of a specific song or a piece of music is also always a difficult task. Even though many musical transcriptions are available in the internet, newer songs are not presented in the internet also. And guitar chords recognition is basically about identifying, extracting and predicting the chords that are played by the guitarist in real time from a video. Another problem in the domain is like when someone playing a guitar or watching some guitar playing tutorial or some kind of video is to reproduce the chords that the artist or some your friend or someone is playing real time. So if the person doesn't have the sheet transcription, which is the chord sheet of that song, it's very tough to recognize and learn the chords by just looking at their hand shapes. So when considering some live music shows, concerts and stuff, most of the time the guitarists are not playing their songs in their original pitch, like, or they are in their original musical scale, and do not the and they do not play their original chord patterns also. So in that scenario, if someone wants to mimic those chords that the guitar is playing, or if they want to reproduce these chords, there's a very big problem in there, like to how to get their chords, how to learn the artist playing chord and their actual music chord sequences also. So when it comes to music composing, guitarists still have to use a pen and paper to write their guitar chord sheets when they are creating when they are creating a new song, when they are to generate musical chords for that songs. They have to add chords by just writing down with a pen uh, when, when they're adding a melody to song. If they forgot to write the chords for a specific song, it might be very difficult them to rethink and start over the melody adding, and also it's very time consuming. Yeah, so when someone plays guitar with the capo attached, due to the capo confusion, beginner guitarists and even for professional guitarists are failing to identify the correct chords that are being played most of the time. And the next thing is like when someone watching a YouTube videos too while they are practicing, and but some videos contain disturbances and background noises also, making it very difficult for players to accurately detect the chords. And also there's a very big problem in with the start of COVID-19 infection. It became the online guitar teaching became less practical. Since the fingers are placed very close to each other while playing some guitar chords, and due to various network connectivity issues, it's very difficult to recognize the chords properly, and also there is a difficulty in correctly identifying the chords played by the tutor. So when you talk about the research gap of the project, so there are mainly two ways of recognizing the guitar chords. First one is guitar chord recognition using audio data, and the second one is guitar chords recognition using video data. So when you talk about the audio, from audio, there are it has been massively researched area during the past few years. So however, the main focus of this research is to mainly focus on video data to recognize the guitar chords. When considering the video chords recognition methods, due to the fact that today's music getting more complex and complex, extracting only the guitar playing part and predicting can be tedious task. Visual recognition of guitar chord is based on based on hand shapes. Each guitar chord has a unique playing style and a unique hand shape. Throughout the current works on guitar chords recognition, the dataset and the method of extracting finger shapes from the guitar fretboard and strings has always been a challenging task of this process. Since there are millions of different guitar types available and each guitar fingers are consisting of different thickness, skin color and other factors also makes the visual chord recognition more challenging. And most of the past researches have been conducted using very limited number of image data for the classification, and they have used only like 300 to 400 500 images, and they are also very quality wise they are not very good, and also most of them most of the existing research have used depth camera sensors and relies on other different physical devices for the prediction, and almost all the existing systems are not capable of identifying the chords when a capo has attached also, and and when considering the real life performance, since because their data set is created by them, and the data set is very dependable on their specific environment, the even though the accuracy is high, it's only work within only within their environment only. And another gap that found during the review of the previous work, which is lack of non-transfer learning CNN approach has been applied to none of the previous works. Almost all the previous work has been done using like pre-trained models or using something like Bayesian classification and several other algorithms. So when you talk about the traditional methods of guitar chords recognition, most of the researchers have used had to rely on physical devices. Some traditional methods have used depth sensors like Microsoft Kinect sensor, Creative Sense 3D sensor, roll and MIDI pickup configuration sensor, and leap motion sensors for to capture the image and extract the image from guitar fretboard and from the background, and they have extracted each finger using these depth camera sensors. And some other traditional approaches have used the special marker system, which includes special gloves in hand to recognize the hands more easily by the camera. And also some other previous works have been conducted using stereo camera system, which makes a 3D visualize for easy capture images also, and some other research have been conducted by using a camera attached to a guitar neck also. So all these kind of methods can be avoided in 2022 by using new technologies such as Google's media pipe algorithm. So when we compare with the existing systems, the best thing about this proposed solution is the proposed solution will only use the user's web camera to recognize the chords actually. So the proposed solution will turn on the user's camera and instantly predict the guitar chords that the artist is playing in real time. So let's move on to the high level architecture diagram. So this is the 3-tier architecture diagram, and this represents in the top layer this is a presentation tier, and in the middle logical tier, and the bottom represent data tier. And in presentation tier, so this is the module that a normal user would see. The landing page of the user interface shows the welcome screen of the system and the instructions on how to use the system and a sample demo. And the presentation layer includes the web application that the users can turn on their web camera and play the guitar in front of the camera. Within few minutes, the system would be should be able to display the real-time playing chords to the user. Then after capturing the real-time footage from the user, then it comes to logical tier. The logical tier contains the main core logic of the system, which will be led to achieve the core functionalities of the chord recognition system. The logical tier will capture the required data from the camera, which is used in the presentation tier, and then the capture data will go through some pre-processing module, and inside the pre-processing module some reshaping, resizing, and color normalization, and some methods will be applied to each data, and it go through with the data tier. The data tier contains the guitar chords data set, and after going through the guitar dataset, and by using the custom created CNN model, it starts the feature extraction module. So with the feature extraction, the chord recognition, guitar chords classification will happen, and each chord will stored in the data tier also. So after storing the respectful guitar chords, then it's again shows in the presentation tier, displays the real time playing chords while the user is playing his guitar in front of the camera. So let's dive into the proposed solution of the project. The main solution is consist of two parts, because in earlier researchers, they struggled a lot in during the dataset creation in image, finger tracking, and they have used various kinds of physical depth camera sensors, but we are in here using only the user's web camera. So I have created a data creation tool for anyone can use that tool for creating datasets for their any kinds of string instruments. So let's go to the demonstration. So here is my first contribution of the research. The first one is my the data. I created a dataset creation tool, which comes handy when dealing with some image processing projects. And what it happens there is like I need to capture images to feed my CNN model. So I have created this data creation tool. So first it asks from the user. So when we run the this code block, it asks from the user to select the code that you want to capture. Let's say I want to capture images of my G chord. So this is the main algorithm of my dataset creation tool, and which works and which mainly based on Google's media pipe framework. And so I set the image height and the width as 200, and I created a separate folder, and I assigned manually defined key point connections, because when you play the guitar, you only need 4 fingers, not without the thumb finger. So I need to remove the thumb finger from my hand. So to implement that, I researched on Google Media Pipe library and removed customly my thumb from the landmark tracking. So then I assigned different best colors for tracking, and you can change the number of total pics that you want to capture. This process of capturing hand images and tracking of the each and every finger. Then I removed my thumb from tracking, and I ran through a for loop to capture each and every frame 500 times. And I also got the count contours also. So to get the contours, I analyzed some media pipe library and OpenCV library and I resized image, and the final frame displays the chord that we are capturing, if it's the G chord, C chord, or F chord, and something like that, and it displays the number of image count. And so as you can see from here, our previously captured data has been successfully saved inside the chords inside the G folder. So as you can see from here, we have created 500 images for our data set, just the G code. So like that you can create data sets for any kinds of code types like G code, C code, A, B, C, A minor, any kinds of codes you can create with my tool. So let's dive into the main research contribution of the project, which is the guitar chord recognition using video, real-time video feed main implementation. So let's go to the code first. So I'll explain. So the first step is to gather the previously created data set and split the data into the training data and validation data and testing data, and I got the ratio as 70 to 20 to 10 ratio. So to divide each and every image set, I used a split folder library for that. So first I have compared different pre-trained model with my model also, which is using VGG16 and Inception pre-trained models, but I got a high accuracy using a sequential customly built CNN KRS model. So this is my main KRS model which I build customly. So I use for initially the 9 classes, and I got sequential model as a model, and I added convolution 2D layer like 32 and 5 and 5 and input shape, and I got the input shape by my image size is 200 and 200 x and y for the x and y axis, and I used the ReLU activation function for that, and after that I used a max pooling layer as a second layer, and with the pool size of 2 and 2, and I use the same padding for that, and after that I again used a con2 layer using 64 with actually with ReLU activation, and after that I for the next layer I added the max pooling 2D layer with the pool size of 5 and 5, and after that I flattened the layers. So after flattening the layers, I added the dense layer. For the dense, I 124 use with the ReLU activation, and I used dropout with 0.6 dropout. And finally, I added the dense layer with for my number of classes. With for the activation function, I have used softmax activation for that. So to compile the model, I used for the loss calculation, I use categorical cost entropy for that, and I use after testing and testing between different optimizers, I finally able to got more robust performing model by using Adam class optimizer. So I used Adam class optimizer as my optimizer and matrices accuracy. So I got the checkpoints for that, and next thing is this is my model creation and as a function. Then I moved with my image data generation. I have used the batch size as 32, and then so after defining the model, I move to uh, image data generate. I use image data generator for my pre-processing for my training data, and I used image rescaling and I shifted the image by 0.2 and shear range. I added shear range, and I added the rotation and zoomed. For my train generator, I use my train directory, and my target size is the image size, and the color mode I got is grayscale. I use the grayscale color mode, and batch size is 32. I use 32 batch size, and class mode is categorical. So I use 44 seed size, and for my training data I use 12,600 image within 9 classes. These are my labeled classes indices like A to G code with minor codes also. So after that I rescale and use validation. This is my validation generator, and this is my testing generator. I use same parameters for all for the consistency. For validation I use 3600 images, and for testing I use 1800 images, which is the ratio of 70 20 10 ratio. So after balancing my each and every classes, so I called my keras model which I defined earlier. Initially, like I got the most optimal or epoch value I got after doing some 10 to 15 different model training. I got the optimal epoch value as 20 without overfitting my model. So then I use model.fit generator for that. So I got the trend generator which I was created earlier, and my validation generator. And after getting then I train my model. So after training my model, I was able to gain an maximum accuracy of 99.41. So that's a very good accuracy for that, and for my these classes. And I visualize my F1 score table, and the confusion matrix, and all are very healthy. So this is my final OpenCV frame, which loads the prediction, which loads the model, and performs the prediction from real time using the web camera. So this is the I'm importing the media pipe and the OpenCV libraries, and keras load model, and numpy to read my images, and then I loaded my model, my previously created model, and I created dictionary after the prediction to get the value. And this is my detection confidence by media pipe and tracking confidence. I initialize as 0.7. And when the webcam is open, then I got the images and processed the image by I converted BGR to RGB, and then I feed the OpenCV library with the BGR color format. So this is contours making. So I applied the threshold for my my OpenCV frame at gray by using CV2 threshold binary values. And so with my keras predict function, it inputs the model and the each and every frame. So then it calls keras process image function by it receives the parameter as the frame as the parameter, and it resizes the image, and using numpy array, it uses MP like numpy float 32, like converts to a numpy array my image. So then after that, the converted numpy array, it gets reshaped with my dimensions. So after that it returns my image. So after returning my numpy array image, it predicts using my model, my previously created model. It predicts predicts the code. So after predicting the code, it gets the index and return as the predicted class. Using the predicted class, using the predicted class, it gets the pred class. By using the pred class, by calling the code dictionary, which is initialized in the top of this code, we can by using the each and every index, we can it represent the corresponding code value. So then I prints the code and the each image of the code also. So this is the home page of the web application for the CHORDEYE, and so it displays the main landing page and the features available, and how the system works, and the gallery of some detection images, and how it works, and the gallery. And let's start the program. So here's the demonstration of the main guitar chord recognition project. So as you can see from here, I am playing different chords within few seconds. Like, as you can see already in the bottom of the page, the plate codes are recording, displaying in each order. So as you can see from here, now I'm playing G chord. From the OpenCV frame, it does not capture audio, so only the video is captured. So as you can see from here, I'm now playing the E minor chord, and also in the display it displays as E minor chord, and now F minor. Likewise, I'm you can real time play the chords, and real timely you can generate and for the evaluation of the project. There are several criteria has been considered, and mainly for the evaluation I have divided into two different sections, which is for domain experts evaluation and the technical expert evaluation. So mainly the evaluation criteria goes like the overall concept, scope and depth, and system design and architecture and implementation, solution and prototype, and the performance and the accuracy at final. So when for the domain expert evaluation, I choose musicians for that. For them I gave the overall concept, the idea of the overall concept, and after that I gave the prototype for them to test it. So which was evaluated by the musicians from studios and guitarists. For the technical experts evaluation, I like the criteria was evaluate the implementation, the scope and the depth and the scope of the project, and the final performance and the accuracy of the system. It was evaluated by using software engineers in various and different companies in Sri Lanka. For the evaluation of the project, there are several criteria has been considered, and mainly for the evaluation I have divided into two different sections, which is for domain experts evaluation and the technical expert evaluation. So mainly the evaluation criteria goes like the overall concept, scope and depth, and system design and architecture and implementation, solution and prototype, and the performance and the accuracy at final. So when for the domain expert evaluation, I choose musicians for that. For them I gave the overall concept, the idea of the overall concept, and after that I gave the prototype for them to test it. So which was evaluated by the musicians from studios and guitarists, like the so also the famous person. And for the technical experts, evaluation, I like the criteria was evaluate the implementation, the scope and the depth and the scope of the project, and the final performance and the accuracy of the system. It was evaluated by using software engineers in various and different companies in Sri Lanka. Finally, the future work of the guitar chord recognition using real-time video feed can be included as the developed application can be improved to recognize more guitar chords type, like the seventh chords, minor chords, more flat and sharp chord, diminished chord, sixth chord, and by creating more and more class. Yeah, so and this application also could be more improved to recognize not only the guitar, but also to recognize more piano chords, other string instrument, violins and cello, something like string instrument, and so on. By just using the my media dataset creation tool, they can just simply create datasets and apply the same implementation. In future, like more faster hand tracking algorithms could be more analyzed to track fast moving fingers to detect the chords more robust. No, and the other thing is no code class could be implemented to track when the hands are not in the frame, when the hands is out of the frame. A no code class could be implemented. The dataset creation tool can be more improved to use as a web and mobile based application, where you can capture data even by using a cell phone camera. Like wherever you are, you can just open the application and create generate datasets. More like mobile phones cameras are more have much more quality than the webcams, so that would it would be very helpful. Like, and the same media pipe implementation can be improved to generate guitar tabs also. So, and finally, this guitar tracking algorithm could be more improved to recognize not only the guitar chords but also to track guitar lead notations, like the lead parts of the guitar solo parts and guitar lead notations, like, and to export them as a guitar notation tab or something like that, so that it would be very helpful. Like, it can be improved in future work.